Hello, I'm Clay Morrison, and this is my Lab 3 lab report. So the purpose of this lab was to determine the distance dependence of a magnetic field for both on-axis and off-axis fields that were induced by a small bar magnet. And this is achieved using a combination of both smartphone technology as well as physical equations. And the physical principles used in this lab were the Biot-Savart law, which, as you can see, relates to this equation right here. And it basically equates the magnetic field to the magnitude, direction, length, and proximity of an electric current. And I also use the distance dependence of a bar magnet, which includes this first equation here, which can be manipulated by taking the natural log of each side into the second equation. And it also includes the equation that from which you can calculate the k value in relation to mu theta, or mu naught and mu. So as for the procedures for this lab, first of all, I use the magnetometer free app, and I align my smartphone with the magnetic north-south axis by determining where the x value of the field equals 0, and subsequently found the location of the magnetometer on my phone. And then I determined the on-axis distance required to achieve magnetic fields with x values of 20, 70, 120, 170, and 220 microteslas. And then lastly, I found dperp, which was the x-axis distance required to achieve a net magnetic field of 100 microteslas. And then after shifting my phone this direction in the x-axis, I moved it up in the same direction in the y-axis, the positive y-axis. And I then recorded the x, y, and z values of the magnetic field at this location. And this was the off-axis value. So as for my on-axis data here, as you can see, my distances to achieve each field is here on the left side, and then the x value of each field is here on the right, and then the averages over here, and then the natural logs down here. And then so entering this data created this graph, which taking the b value here, I can plug that into this equation, and using that value, I can get k by raising e to the power of that, which gave me 1.07 times e to the negative 6. And then using the equations I mentioned earlier, I can calculate the mu value, which I got to be 5.53 amperes times meter squared. And as for my off-axis data, here are my 3D perp values, as well as the magnetic field of Earth, which I compensated for in the y value, in the corrected y value here, and then the magnetic field, the x value magnetic field, the z value. So using the x, corrected y, and z magnetic field values, I put them together to get the magnetic field at 45 degrees, which gave me this. So getting into the coding here, of course, I first centered the magnet at the origin, and then created a function using the Biot-Savart law equation here. This is basically just scaling, and then I set my my observation, my on-axis, my two on-axis observation locations, and my four perpendicular observation locations. And here I drew the two arrows to represent the on-axis magnetic fields, and these were the four off-axis perpendicular arrows. And then finally, using my dperp values, I was able to draw the arrow at the observation location 45 degrees to the phone and magnet. And so running that and running the code here gave me this model. And so the orange is the on-axis, which points to the right, and the blue is the off-axis, which points to the left. And then you can see the green value here at 45 degrees. And so here are my 3 and 4 off-axis values. You're welcome to open my the link to my code to see my other values, because they kind of got cut out here. But then this is my magnetic field at 45 degrees. So as for the conclusion questions, so if I hadn't oriented my experiment to compensate for the magnetic north, and instead laid it out at some arbitrary angle, it would have changed the x values because compensating for the magnetic north, as I mentioned earlier. initialize the x value at 0, so the magnetic field would have changed based on how the x value changed. And then so if I were to stick two identical magnets together and run the experiment again, the two magnets would theoretically act as a larger magnet and would therefore result in a magnetic field with a magnitude approximately double that of the original. It's not necessarily exactly double, but it'll probably be in that area. So that concludes my presentation. Thank you for listening.